to this new video where we will be seeing the setup of a membrane switch from 0 to 100. What is a membrane switch? This guy is a rubber button switch. It's very used in modern electronics, the good substitution for mechanical switch, is cheap and is very well working. What we will be seeing in the video, we'll be setting up a membrane footprint in KiCad, which is missing as a footprint in the standard library. We'll be setting up machining files, so G-code files in FlatCam. We will be milling our PCB, and finally we'll be testing a final prototype. As always, I would like to kindly ask you to subscribe to the channel, to give a thumbs up to the video if you like it, and to hit the bell to stay tuned. And let's get started. First of all, let's open the footprint editor inside KiCad. And there you go. It usually takes some time because it has to load the entire library of all the footprints. And there we go. First thing first, we're gonna create a new library where we'll be saving our footprint. That's it. And second, we will be loading the new library inside KiCad. That's it. And there you go. And last thing, we're gonna create a new footprint, which obviously will be empty. And we're gonna name it. And there you go. First thing first, we're gonna create a circle in the margin layer in order to keep out tracks and vias. Second, we're gonna create a seal screen area for the control in order to make it visible on the PCB. Then we're gonna create a center area again in the layer of the margin, again to keep the center clear from vias and tracks. Then we're gonna set the two lines in order to set the distance for the two holes that will be needed to set the extrusion that there are on the button to fix the button on the PCB. These holes are NPTH, so non-plate through holes, which means that they don't have tin and they are just two simple holes which will not be needed for any solder during the process of mounting. That's it. Then we're going to create the first inner circle on the copper layer. This will be the first contact line for the membrane switch. Then we're going to create an arch, which will be the second circle, the outer circle, which will be the second contact line. This is an arch and not a circle because it has to be open at some point. Then if we inspect, you see that we have a problem. The two circles of copper are covered by the mask, and this is not good because the contacts have to be exposed. So we create two copies and we put it on the mask layer in order to uncover the copper. As you can see now, the copper is exposed with respect to the solder mask. Then we are going to divide the two circles in 9 equal parts. This is something that requires a little bit of math and of work, and is not really needed from a, say, a technical perspective. It's just to have a result which will look a little bit more professional and ordered. You don't need to be super precise here, but yeah, a little bit, let's say, correct, I think is needed. I'm gonna clean up a little bit to make the things more visible. again, we're gonna clean a little bit. Then we are ready to set on the copper layer some more copper, as you can see, connected to the inner circle in this case. And again, you're gonna create the copy and put it on the mask layer in order to uncover the copper and make it exposed with respect to the solder mask. Maybe there is another method to obtain the same result, but I know this one. If you know a better method, just put it in the comment. That would be more than welcome. And then we do the same thing on the outer circle, trying again to respect the lines that we drawn. And we create the copies on the mask layer. Going to inspect, want to clean it a little bit, and then again we inspect, and that's it. This is good. Now we're going to create the two parts that will act as connectors for the tracks, for the lines that we will drawing inside the PCB. It's one per line, so as you can see, one is connected to the inner circle and the other one is connected to the outer circle. And there you go. And that's ready. The footprint is ready. Now we're gonna create the PCB that will be hosting this footprint, and that we will use to test our footprint. So first of all, we need to add a simple switch SPST symbol. You don't need to find anything particularly fancy. I use the simpler one that I find into the KiCad library. There you go. Then we assign our new footprint, and there you go. Then we're gonna add pin headers to connect for testing. Better to shape it in the other way around. There you go. And we assign again the footprint of the pin headers for 2.54 distance. And finally we're gonna add 4 mounting holes. You will see that in the test that we will be doing, we'll not be using it at the end of the day, but why not? And finally we're gonna move everything onto the PCB. As first thing, we're gonna create into the edge cut layer the PCB size was gonna be 28 by 28. Gonna place the membrane button footprint, the headers, and the 4 mounting holes. And there we go. And now we start tracing. But we have a problem. The circle that we did on the margin is completely blocking the possibility to connect. So we have to make a change. We cancel the circle, and we draw an arch instead in order to let open and allow us to connect the two paths. And that's it. Now the two paths are connected. I'm gonna create a ground plane. That's it. We're gonna fill in the copper. And now we're gonna export the Gerber fabrication file that we will be using in FlatCam in order to generate then the G codes. That's it. And we move to FlatCam in order to generate the G code. First of all, we have to import into FlatCam the copper image from our Gerber, which is this one. And there you go, this is the copper image. Once we have imported the copper image, we have to generate a geometry for the milling. We set the diameter tool, we set some other parameters, and then we generate the geometry like you can see, as you can see. Then we're gonna do the drilling for PTH hole, so the whole plate. There you go. These holes are 1 mm. We don't need to generate the geometry here because we use a 1 mm tool to drill the hole. And then we do the same for MPTH, the one not plated, but in this case these are 2 mm and 2.2 mm. We still use a bit of 1 mm, so we need the geometry in order to generate. This is the 2 mm and this is the 2.2 mm geometry for milling the holes, and that's it. Then we're gonna generate the geometry for the board cutout. And there you go. Moving on, we need to generate the CNC object from the copper geometry. We set how much we want to go in deep. We set once again the tool diameter, and that's it. As you can see now in blue, you can appreciate the CNC machining work that the milling machine will do on the copper. So we're gonna do the same for the 1 mm drilling, PTH. There you go. And we're gonna do the same for the 2 mm and PTH holes. That's it, 1 and 2. And finally we do the same for the 2.2 mm holes, and all the holes now have the CNC job defined. You just need to do the same for the cutout, for the board cutout. There you go. In the case of the board cutout, we will be using a 1.5 mm bit, and that's it. Now we are ready to export from the CNC objects the G-code file. First of all, we export the G-code file for the copper. There you go. Then we are gonna go for the 1 mm PTH hole. Then we are gonna go for the NPTH for 2 mm, the NPTH for 2.2 mm G-code, and finally the board cutout G-code. And that's it. Let's go now for the PCB milling using my hand milling machine. we go. The PCB is done. Now we separate it from the main copper board. And that's it. And then we go for the final testing of what we have done. Here you can see again the final PCB. I have soldered the pin head. That's it. And this is the switch, the rubber switch that we put onto the PCB and we fix through the two extrusions. That's it. As you can see, it's perfectly clickable. Then we take a cradle, a box that I have designed and printed with my 3D printer, and we put inside the PCB. There you go. And we cover it with a cover. And the test is complete. We now connect it to the board, check the green lights, and that's it. As you can see, it works perfectly. And it's also very precise. In order to even better test precision respect to bouncing phenomenon, I've modified the software, and now we have the block, and as you can see, it works perfectly. It doesn't miss one click. That's it. Thank you very much for following up, and see you in the next video.